everybody. In this video, we're going to talk about multiplying whole numbers. And again, don't forget to put your date up top, or at least the week in which you're reading and working through this. So the first thing you want to note is that multiplication is really just repeated addition. So for instance, 5 plus 5 plus 5 is the same thing as 5 times 3. So multiplication is really just a lazy way to write addition. So it's repeated addition over and over and over again. And the one thing we want to keep in mind, though, is that multiplication symbols can vary. Okay. Now, I'm going to use the 5 by 3 example here. Now, obviously, 5 times 3, using that little X symbol, is a very common way to write multiplication. But we also have other symbols too. So we can use a raised dot like this. You can also use parentheses. So you'll see parentheses on both of them, or you may see parentheses on just one of the numbers, like this. Usually for parentheses, it's either this way or this way. It's very rare that we put the parenthesis just first, but it could work. So basically, if you see things touching like that, and there's no plus or minus or any symbol in between them, then you have multiplication. So these are just some ways that we can express multiplication. If you're on a computer, you may often see it with that little asterisk symbol like this, that kind of little star symbol. So if you're on a computer, again, just to note, you may see it written that way if you see typed notes or if you're typing notes, things like that. So there are different ways to write multiplication. For now, I'll stick with the X, but you're going to see that I will go away from that soon once we start getting into things like variables. So we don't like to use this X symbol as much for multiplication because it can be confusing and look like a variable later on. Okay, so let's talk about some properties as well. So the first property is the multiplication property of 0. And what it says is the following. So it says the product of 0 and any number is 0. So for instance, three times 0 is 0, or 0 times 10 is 0, and so on. Now, one thing I forgot to mention, I should say, are some of these key terms here. So let's actually make another column up here and just do some quick definitions. So that word product, which is seen here, I forgot to mention, and it is the answer to a multiplication problem. Okay. We also have the term factors, and these are the numbers being multiplied. So for instance, if you had an example, something like 3 times 2 equals 6. 6 is our product, and 3 and 2 are our factors. Okay, so that word product just means the answer to a multiplication problem. Another property, and there's quite a few, is the multiplication property of 1. And what it says is that the product of 1 and any number is that same number. So for example, 8 times 1 is just 8, or 1 times 7 is just 7. Now, this is also called the identity property of multiplication. So that's the more formal term. If you see it, usually we say that in an algebra class. And the reason is because the number 1 allows the identity to remain the same for the other number when we multiply with it. So multiplying by 1, it doesn't change the identity of 8, doesn't change the identity of 7. So we also call this the identity property of multiplication. Okay, I'm going to go to the next page. We do have 2 more properties. This is 3. Just like with addition, we do have the commutative property of multiplication. Which basically it says that changing the order of the factors will not change the product or the solution. So again, for example, 4 times 6 is 24, and 6 times 4 is also 24. So like with addition, we can rearrange the order for multiplication. And we also have the associative property. Of multiplication. And just like with addition, this basically says that we can regroup and we're not going to change the answer. So changing the grouping of factors does not change the product, or again, the answer. So for example, let's say I had 1 times 4 times 5. Now, again, we typically do numbers in parentheses first. So this would give me 1 times 4, which is 4. So I have 4 times 5, which is 20. Or if I wrote it the other way, 1 times 4 times 5, right? I would do the 4 times 5 first, which is 20. And 1 times 20 is also 20. So you can see we get the same answer whether we rearrange the order or whether we rearrange the groups. It doesn't matter, which is really nice. So this here is unique to addition and multiplication. We cannot do the same thing with subtraction, and we cannot do the same thing with division, which we'll see as well. All right, and there is a 5th property here. And that's called the distributive property. And this is one we're going to see a lot. We see a lot in algebra courses is the distributive property. So basically what it says is this. All right, so I'm going to write it in general form. So I'm just using letters here to represent any number that could be. So basically, if you have a number being multiplied on the outside of parentheses with addition or with subtraction on the inside as well, then what it says is you can take that outside number and multiply it to both numbers inside the parentheses. And if you're adding, you just use a plus symbol in between. And if you're subtracting, you just use a minus symbol in between. So it says that we can actually distribute that multiplication throughout the parentheses. Okay. All right, so let's look at a couple of examples here. So what the distributive property says is we can do the following. So we can take that 5 and we can multiply it to the 4 and to the 3. So we're going to get 5 times 4 plus 5 times 3. Well, 5 times 4 is 20, and 5 times 3 is 15, and then if we add these together, we get 35. Now, as a little side note, it would be the same answer if we didn't distribute. So if we did the parentheses first, 4 plus 3 is 7, and then 5 times 7 is 35, right? Because 5 being with parentheses means multiplication. So we get the same answer. So you may be asking, well, why do we do it this way? This way is kind of longer. And that's because once we get to variables, we're not going to be able to simplify like this. We're going to have to use the distributive property. So that's why we're introducing it now. Let's do another example. Okay. So 2, 10 minus 8. So I can do 2 times 10 minus, and then 2 times 8. Now we multiply first. 2 times 10 is 20. 2 times 8 is 16, and I get 4 for my answer. Now notice if I did it the other way, 10 minus 8 is 2, and then 2 times 2 is still 4. So you get the same answer. I do want to show you one last example. So it's very rare, but you can write the number on the other side. So let's say I wrote it like this. This also is the distributive property. Again, we don't see it as often. Usually we like to put the number first, but it means the same thing. Notice that there's no symbol in between. The 3 is touching the parentheses. So you can distribute inside here. So you'd have 5 times 3 plus 1 times 3. So 15 plus 3 is 18. And it'd be the same thing. 5 plus 1 is 6. 6 times 3 is also 18. So we have that distributive property here, which again is going to be really helpful once we get into variables. All right, so now that we're done all the properties, let's actually just review how to multiply whole numbers. So let's start with a few and run through a few different examples here. So maybe we will do, let's see, 25 times 6. So I am going to line this up vertically, just like I did for adding and subtracting. And we do typically line it up on the right by the place value. Now, what happens is we do multiply a little differently though. So instead of kind of lining up with columns, we almost work diagonally a little bit. So we still work right to left. And what we're going to do is take this 6 and multiply it through all the digits up top. So we're going to start by doing 6 times 5 first. So 6 times 5 is 30. So what I do is I put the 0 from the 30 and I carry the 3. You really want to make sure you know your multiplication tables here. So if you don't, you may want to go online and find a multiplication table so that you can review those, just so that you know all your facts. Now, once we've done this piece here, then we're going to do 6 times 2. So 6 times 2 is 12. Okay. But we have this 3 here. So what we're going to have to do is add that 3 in. So we actually get 15 here for our final answer. Now, I don't have to carry anymore because I have nothing left to carry to, so I can just bring that 5 down. So our answer here is 150. Let's do another example. How about 312 times 8? So again, we're just going to start working right to left. So I start with the 8 times 2. So 8 times 2 is 16. So I put the 6, I carry the 1. Next, we're going to do 8 times 1, which is 8. But don't forget you have that extra 1 up top here, so you do have to add that 1 in, and we get 9. And then finally, we do 8 times 3, which is 24. And nothing left to carry, so I just write the full 24 down. So my answer here is 2,496. Now, if you're very comfortable with multiplying, you obviously do not have to write all these steps on the side. I'm just kind of writing them out for people who haven't seen it in a while and need that extra review. So we're always working right to left. And just like with addition, we do have to carry any tens positions. So you just want to keep that in mind. Sometimes this can get a little confusing. So be really clear, give yourself enough working room. So notice that I've kind of spread my numbers out a little bit here as I wrote them. I didn't write them too close together. It just makes it easier to see what you're doing and stay organized. If you want to put those vertical lines in again and you find that helpful, you can do that too. Use color. So I recommend using different colors, whatever helps you. So now let's take it up a level here and multiply by a 2-digit number. Okay. So let's do 312 again, but this time by 84. So I have 312, and I'm actually going to use different colors for the digits this time. So I'm going to multiply that by 84. Okay. So what we're going to do here is we're going to do the same procedure that we did above, but we're just going to do it 1 digit at a time. So I'm going to work with the 4 first, multiply by the 2, the 1, and the 3, and then I'm going to work with just the 8 and multiply by the 2, the 1, and the 3. And that's how we do multiplication by hand. Okay. So I'm going to start with 4 times 2 is 8. 4 times 1 is 4. And then 4 times 3 is 12. Now, notice that I'm staying lined up. This is so important with multiplication, that you stay in order, that you stay lined up. Now, what's going to happen is as we go to the 8 now, so I finished with the 4. As I go to the 8, I need to start writing my numbers underneath the 8. So what a lot of people do is they will put some number here, a 0, an X, just something to remind themselves that they need to start under the 8. So I will put a 0 with a line through it. The reason I'm going to put the line through it is to remind myself that it's a placeholder and not that I multiplied and got a 0 answer. Sometimes that's really tricky. So let's say I multiplied and I had 5 times 6 and got 30. Sometimes students will mix that 0 up with them already having put the 0 down from 30. So I like to put my placeholder here and I'll put a line through it to remind myself that that is a placeholder. So now I start with the 8. I'm going to do 8 times 2, which is 16. So I put the 6, again, starting under the 8, and I carry the 1. Now I do 8 times 1, which is 8, plus the 1, which is 9. And then I do 8 times 3, which is 24. Once you have that done, you are going to add your rows. So I have 8, 6 and 4 is 10, carry the 1. 2 plus 1 is 3 plus 9 is 12, carry the 1. 1 and 1 is 2, plus 4 is 6, and then 2. So my answer here is 26,208. All right, and let's do one last example. I want to multiply by a 3-digit number this time, so you can see that this time I'll have 3 rows underneath. So let's do about 581 times 146. Now the order doesn't matter, so I can put any number on top or bottom that I want to. That's fine. I'm just going to stay in order here. And notice I'm just spreading out a little bit. I'm lining up. I'm giving myself some room. And I'm going to go ahead and start with the 6. So actually, here, I'll make this the pink. We'll make the 4 the blue. I should have done it beforehand. 4 will be blue. And then we'll do the 6 so we can kind of follow along a little bit. So for the first row, I'm going to start with the 6. 6 times 1 is 6. 6 times 8 is 48. So I put the 8 and I carry the 4. 6 times 5 is 30. Plus 4 is 34. Now, you may want to circle how I did in the other ones, or when you're done using it, you may want to cross it out so you don't mix it up with the next row. Now I'm ready to start the 4, so I need to line up under the 4. So I'm going to put, and now I start just the 4. 4 times 1 is 4. 4 times 8 is 32. So I put the 2 and I carry. 4 times 5 is 20, plus the 3 is 20. Now I'm lining up under the 1. So what I'm going to do is I'm going to put in 2 placeholders this time so that I line up under the 1. 1 times 1 is 1. 1 times 8 is 8. 1 times 5 is 5. And finally, I'm going to go ahead and add this all up. So I have 6. Here I'm going to have 12, carry the 1. 1 and 4 is 5. 6, 7, 8. Here, 3 plus 3 is 6, plus 8 is going to be 14. And then 1 plus 2 is 3, plus 5 is 8. So I have the value 84826. And putting in my commas on the right, do 3 spots in, I see 84,826. Okay, so each time we go down and add another digit to that second number, we'll have to add another row. So just something to keep in mind here. All right, let me get myself a little bit more paper. All right, so let's keep doing multiplying, but let's do it with some applications now. Okay, so again, I'm still in the same lecture, but I am going to just highlight that I'm kind of talking a little bit about not a different topic, but a kind of part of this topic, specifically about applications. So one thing I want to talk about here is the area. And area is a two-dimensional idea. So perimeter was one dimension, just going around the edges. Area is two dimensions. And typically for things like rectangles or squares, we're looking at length times width. So if you have a rectangle, okay, let's say this is your length and this is your width. Well, the area, which we usually abbreviate as A, is going to be your length times your width. If you have a square, it's actually the same thing, but what happens is your length and your width are the same, so we often just call it a side. So your area is equal to the side times the side, which some of you may know as side squared. We'll talk more about exponents in a little bit, so don't worry too much if you're not familiar with that notation yet. But you're just multiplying those two sides together. And again, you can really still think of it as length and width. It's just that with a square, your length and your width are the same. Okay, so you can just label it as side instead. One thing you want to notice when you have area is that you do have square units. So when you multiply your two sides together, you're going to multiply your units as well. And this was different than perimeter. So with perimeter, excuse me, not perimeter, perimeter, we were adding up the sides. So when you're adding, you don't have to square your units. But because we're multiplying, you do have to multiply your units together. So you end up with square units here. So let's look at an example. Okay. So let's say I have a rectangular garden. And maybe it is 6 feet by 12 feet. And I want to find the area. Well, the area is going to be your length times width. It actually doesn't matter which one you call length and which one you call width in a diagram like this. In a field that you're working in, they may be more specific, right? So you may have specific ways to label, but just in this picture, it really doesn't matter. So our area is going to be the length times the width. I'll call this my length and I'll call this my width. So I'm looking at 12 feet times 6 feet. Now, 12 times 6 is a multiplication factor. It is 72. And then what happens is when you get feet times feet, you end up with feet sort of squared. So how do you write that? So you can either write that one of two ways. You can write that as 72 square feet. Sometimes we'll write it as 72 SQFT, so square feet. Or you can write it like this, 72 feet squared with a little square symbol as that exponent. And they're both acceptable ways to write it. So you'll notice that in mathematics classes, we tend to write it like this. But, you know, if you went to a store, they may write it like this, or they may write it like this, square feet. So you could write it that way as well. I want to talk about some key words here too. So I know we did keywords for adding and subtracting. So there are keywords for multiplication. These ones are pretty simple. So the word product we've seen before. Obviously, if you see the word multiply, and from when we're little, that word times, right? 5 times 4, something like that. Now, another word that we're not going to see so much today, but we will see a lot when we get to percents, decimals, fractions, things like that, is the word of. Of is a really, really big one for multiplication. But again, it's typically used more when we're talking about multiplying with percentages or fractions or decimals, things that are parts of a whole. But I'm going to put that word of in there now, just to show that. Okay. So let's do an example. Let's say we go to an amusement park. So let's say Tim and Sue bring their children to an amusement park. tickets for adults are $15. Tickets for children are $12. If they have 4 children, how much will they spend on tickets? Now, there's a few ways to do this. So one way is to just add up all the ticket prices for the 6 people who are going, right? Tim and Sue are 2 adults, and then they have 4 children going. So you could add those 6 values up, and that's perfectly acceptable. Since we're doing multiplication, though, we could break this down into 2 multiplication problems. So for the adults, there are 2 adults, and the tickets are $15 each times 2 adults. And then for the kids, the tickets are $12 each times 4 kids. Now, if you can do this in your head, great. If you can't, you can multiply it out. So what we could do is do 15 times 2. 2 times 5 is 10. So I put the 0, carry the 1. 2 times 1 is 2 plus 1 is 3. So I get $30 for the adults. And then for the kids, 12 times 4, that's a multiplication fact, that's 48. But again, if you're not sure, you can always multiply it out. 4 times 2 is 8. 4 times 1 is 4. So I have $48 here. So if I want to find out how much they spent all together, then we're going to have to find the total. So 30 plus 48. And again, some of this I know you can do in your head. But if not, you can line it up. Okay. And we'll see that Tim and Sue are going to spend $78 altogether for tickets to the amusement park that day. And I just want to do one last example here. Okay, so let's say that Tim and Sue are at the amusement park. The average wait time per ride is 12 minutes. All right, maybe they're at like a big amusement park where it's long lines. So the average wait time per ride is 12 minutes. Estimate by rounding each wait time to the nearest 10, how many minutes they will have to wait to ride 6 rides. So here the average wait time per ride is 12 minutes. We're going to estimate by rounding each wait time to the nearest 10 how many minutes they'll have to wait to ride 6 rides. Now, I know the number 12 is not too difficult to work with, but maybe we were doing something a little bit more large scale, right? Maybe we're doing this all day. So maybe we're going on more than just 6 rides. So if I look at that number 12 minutes, and I want to estimate this by rounding to the nearest 10, well, I'm going to underline that 1's position. That 2 is in the small category, 0, 1, 2, 3, 4. So this value is going to stay. So this becomes about 10 minutes per ride. Now 10 is much easier to work with than 12 is. So if we're doing 10 minutes times 6 rides, then we can see we have to wait about 60 minutes in total. And again, this is approximately, right? It's not going to be an exact answer. And again, these are average wait times. So it could be some rides have longer waits, some rides have shorter waits. So this family is going to estimate that if they want to ride 6 rides, they're going to have to add in a full hour of wait time just to add those to ride those rides. So maybe they're trying to plan their day. They want to ride these 6 rides before lunch. So they're trying to figure out, okay, well, we know how long the ride is. We know the wait time. We know we have to walk to the different rides. Can we do it, right? Can we estimate how long that's going to take us? So here are just a couple applications with multiplying.